Okay, these are mud fossils, and I'm going to show you how to go out and find your own in a matter of minutes. And virtually every rock you pick up, you're going to be able to find is a mud fossil. It just happens to be the way they work. And what you're going to find is there'll be veins and arteries in rocks. You see, the vein will be black, and the artery will either be clear or white or open, or it may even be a little red. But that's the difference between the two types of blood. Black is the used up blood, and this side is either blown out because there's no restrictions. It blows out when you die. The veins don't, because there's clamps inside. But this is what you're looking for: veins and arteries. You're looking for the blood is what preserves these things, and the veins and arteries will show up pretty well. Sometimes they're hard to see, but you'll see those, and then you'll see and I'll show you this very shortly, how to see where the lungs and so forth, and the bones, how the bones show their articulations. But you won't see bones looking like regular bones that you see when they put them in the museums, because they're getting them out of the old dried up scraps. These are literally the lungs. This was the lung. Well, actually, this was this one wasn't tested as human, but it bled profusely blood. This one was tested as human, and that's the investment of the bottom. And that tags it in here, and then there's one at the top, and that tags it in here, and this is the fabric, and this is the structure of the pattern of the lung, and I'll be showing these in the microscope, and you'll be able to see what these things are, how they look, and how you can find them. And they're all over the place, so I don't have anything special here. And everybody I've shown how to do this, and all the people that have been on my group, which is Mudfossils, a new science, they've all found the same stuff, so very quickly too. Some of it's very spectacular, actually. Alright, it's a little tough to script this thing, so I'm just sort of going to roll through it. And I'm going to show you how to go out and find mud fossils on your own today, and just go walk out in the backyard or in the woods or wherever you can find rocks. And I'm talking about rocks that are like chunks of rocks that you find around. And then I'll show you how to look at those and determine whether they're mud fossils or not, and what body parts they are. Now, what I have here is virtually almost all of these are lungs. Now, that's a lung that has been CAT scanned and everything. You can see the red on it right there. That's the ferrous oxides that are from the blood. And this was in a volcanic area, and it leached out all the stuff. Now, it leached out all the organic matter, and this is the scaffolding of the lung. And you can see the red and the black, which is the FeO3 and the FeO2 blood that is oxygenated and not oxygenated. Now, over here, if you look carefully, I don't know if you can see this or not, I'm trying to get it in the light, there's a little crystal here. And those are what happens, is crystals grow in the vugs, in these voids that are created when the organics leach out of the scaffolding, the collagen type 1 minerals that make the structural part of your body. When all the gooey stuff, the hydrocarbons and methanes and all that, literally leach out of here, bubble out of here, and give off methane gases, what's left are holes, and those holes are called vugs. Now, and you don't see these unless they were in hydrothermal, geothermal areas where they boiled out the contents. And bones, they boil out the contents, the spongy bone inside, and they leave the bone ball, and that creates these crystals inside the bone ball holes, and they're formed geodes. Now, this is a bone that is a mud fossil bone, and you can see the articulation is 100% complete. I'm going to come in here a little closer. Hold on. Alright, this is a little better lighting. Now, this is a bone and it's the head of a bone, and it's broken here. And if you could see, and I'll show this later in the microscope, but there's a little portion of the bone that is still intact. But what happens is in wet conditions, in mud fossils, they get invaded, and all the bone material is calcium and phosphates and these highly reactive chemicals and minerals, and they bond with all kinds of things. So you don't see the actual bone. That's why everybody, oh, where's a bone? Well, you don't see bones in mud fossils. You see the entire thing, and where the bones were, you're going to see these black investments and red and so forth, because that's what blood turns into, and the bones are loaded with blood. Now you're also going to see the outside of this, and I'll show you in the microscope, which is the fascia. And of course it has the articulations of the blood and the nerve holes, and this is what's called the ligament investment, and all those little tiny holes are where the fibrils invest in there, so it can pull the bone back and forth. And that's what this is, a bone. And if you look carefully, I don't know if you can see this or not, but there's a crack that runs down through there, and that crack is literally the cartilage heads. And these are the cartilage tabs that are on the bone. You don't see these like this in the bones they find in the sandy soils, because they don't. All of the organics are stripped. You wouldn't see any of this on the outside. You wouldn't see any of this cartilage. You wouldn't see any of this where the ligaments invest. It'd be totally different looking. So, and that's why people can't get their heads around mud fossils. All right, now I showed you this one here, and this is a lung, and this is the architecture of the lung, and there's an investment up at the top that holds it, and then there's one at the bottom that anchors it so that it doesn't flop around in the bodies. Now that's one that's been leached out. You have other ones that are like this that have, you see all these different little granular looking things. That is what happens with the little holes that are inside when they don't get in volcanic conditions like this. And I have most of them are this way right here, are filled up with particulates, and that's where the tubing of the lung goes in, and of course they have the same thing, the investments at the top and the bottom. Now when you see one like this lung came out of the ground and literally bled all over. This is the bottom of the lung, and that's the whole structure of the lung. And over on here, it's hard to see, but these are really the lobes of the lung, and the plumbing goes in this way. Now, I have one here that this was DNA tested. And this is the fabric that we're going to be looking for on mud fossils. It's a white fabric, and what this does, this fabric is called fascia. And fascia invests itself around and holds on to all of these different organs and muscles and fibers and tendons, and it separates everything out from everything else. It's made to work in wet environments, and it separates out the wetness of your stomach away from the wetness of your lungs, and it's like everything's wrapped in plastic bags. That's the investment of the bottom of the lung. Now this was DNA tested, and that's the top investment, and it's a human lung, and this is the architecture of a human lung. But anyway, you may not find a lot of these really. These are spectacular, complete organs, and you may not completely see these, but you're going to see there's all kinds of lungs. They're everywhere, and some of them are fossilized in the actually dirty mud, and this has the fabric on it, and this is another lung. They pretty much have the same architecture. Now here's a lung that is partially deteriorated. There's a lining on the top. It's called pleura, and that covers the whole thing, like that fabric coated one I showed you, and then it works itself down into the bloody layers, and that's very obvious inside the microscope. You can see all of the different bloody little vesicles of the heart, the little holes that are in your heart, in your lungs, I'm sorry. This is a lung that, there's the red spot at the top there, is where it invested. Now, I don't know, they could be all kind of different animal lungs, but they could be all human too. But the one I tested, this one here is the human. The rest I can't tell you for sure, but they're lungs, I can tell you that for sure. And this is a lung, it's from a little animal or some sort of animal, I don't know what, and that's where the tubing went into the side of the lung, like you see here. They follow the same structure, and these little lobes of the lung, you may find something like this, you may not, this is kind of unusual, but this shows all the lobes, and they bled all out here. And I mean, it bled, it literally bled drops of blood leaking on the counter. That was several years ago. And this one here happens to be the whole body of a creature, the back of it apparently, and this is where the lung lobes were. And that, if you look carefully, there's a stripe layer there that is the silica layer, and I'm not sure whether that's the backbone or I believe it's some form of a bone. And then beyond that, there may be the ribs, I'm not sure about that, and then it comes into the fleshy black ferrous stuff, and then there's some bone chips in here that are either his ribs on his back or the ribs on his front, one way or the other. But this is a lung assembly, and that is the lung lobes. You see all the holes in them and everything? So it was laying in this and it came down on this, and it washed away and left all that, and below is our creature's lungs. That's the rest of the lungs, and then you run into that line, which is either the back or flesh, I'm not sure what, but it could be tested. And then I believe these are the rib bones that have, you know, obviously not are stone, and this is the lung, and you can see all the pieces of bone all over it, which were from the ribs. Now, what you're going to notice about the lungs is they almost all leak from where the tubing goes in on the side, like here. So you'll see this type of a structure here. All right, so here's your lung, and that's where the lung went inside. And when you look at them carefully, you need to get a good jeweler's loupe or something. You can see the articulation, and I'm going to show you that in the microscope. I'll show you all these in the microscope in a minute. And they all have that. Now, blood will leak out, and this is what happens, is that blood has leaked out of this little lung, and it's been crushed and molded around and so forth. But you can see the fabric, and I will show you that. And this is where there was an investment into it, where the tubing went in. I believe it's right here, and it leaked. And what it leaked out was red blood and black blood. And the red blood is the FeO3, which has excess oxygen, and the black blood is from the other part, which is the entry of the blood that's going to get picked up in here and collect oxygen. The red is already oxygenated. So, and rocks don't leak like this. They leak blood, because what was inside here was loaded with blood. It was a lung, and that's where the articulation. There's a entry hole here where it went in the side and just leaked out here for some reason back here. Must have got cut and broken or something. But that's the way these lungs work, and I'm going to show you these in the microscope now.